Today we're diving into some truly mind-bending research. It's about a new AI model called Tribe, and it's giving us a way to map the human brain in 3D that we've never, ever had before. This could really change how we understand our own minds.
So let me ask you a question. Think about watching a movie. You've got the images on the screen, the dialogue, the soaring music, the sound effects, and your brain just gets it. It combines all of that into one single, seamless experience. But how? Seriously, how does it do that? For the longest time, that simple question has been one of the toughest nuts for science to crack.
And a big part of the reason it's been so hard to figure out is that historically, neuroscience has had to study the brain in bits and pieces. It's been a pretty fragmented science.
Yeah, a really great way to think about it is like this. Imagine you're trying to understand a beautiful symphony. But instead of hearing it all at once, you can only listen to the violins for an hour. Then you listen to just the trumpets, and then just the drums. You'd get really good at understanding what each instrument does, for sure, but you would completely miss the music, the magic that happens when they all play together. Well, that's kind of how we've been forced to study the brain. One sense at a time, one little piece at a time.
So you can see the old approach here had three big hurdles. It was unimodal, meaning it could only handle one sense at a time, just vision or just audio. It was linear, assuming that brain responses were simple cause and effect, which they almost never are. And it was subject-specific, meaning a model built for my brain wouldn't work for your brain. You had to start from scratch every single time. The goal, the new dream, was to create a single model that could smash through all those barriers, one that's multimodal, nonlinear, and works across a bunch of different people.
And that right there brings us to the breakthrough, the solution, a new AI model that was specifically designed to listen to that whole orchestra at once. It's called Tribe.
Tribe stands for Trimodal Brain Encoder. And that trimodal part, that's the whole secret sauce. It's an AI that learned about the brain by basically binge watching movies. But it wasn't just watching. It was processing the three key parts of the movie all at the same time: the video, the audio, and the text from the subtitles.
So how does this thing actually work?
Well, from a bird's eye view, it's a three-step dance. First, you feed it a movie, the video frames, the audio, the subtitles, the whole shebang. Second, it has these super smart AI helpers that go to work, pulling out all the important patterns and features from each of those streams. And then for step 3, Tribe's main engine, a transformer, which is a really powerful type of AI, takes all those different patterns and weaves them together to predict what a person's brain activity would look like. Specifically, it predicts their fMRI signal, which is basically a map of blood flow that shows us which parts of the brain are firing up while they watch that same movie.
Okay, so you have this fancy new model, but does it actually work? I mean, really work. The creators wanted to find out, so they did what any confident scientist would do. They entered it into a huge global competition to see how it stacked up against the rest of the world.
And the results? Well, they speak for themselves. Tribe didn't just place. It didn't just do well. It came in first place out of 263 international teams in a massive challenge to build the best AI model for decoding the brain. So yeah, this isn't just some cool idea. It's officially the best performing model of its kind on the planet. And this chart right here is the proof in the pudding. It shows us why it won. If you try to predict brain activity using just video, you get a certain level of accuracy. If you combine audio and text, you do a little better. But look at that third bar. When you combine all three, video, audio, and text, the full Tribe model, the accuracy jumps to the highest level. It's the perfect demonstration that to understand the brain, you have to listen to the whole orchestra. And get this, it's not a one-trick pony. The model was mainly trained on episodes of the TV show Friends, but it's incredibly flexible. It can accurately predict brain activity for totally different things, like nature documentaries, animated movies, even for silent films, where it has to figure everything out from just the visuals alone. It's just that good. Okay, so this is where things get really cool. Because Tribe is so accurate, we can now use it as a kind of flashlight. We can pop the hood, look inside, and see what the model has learned about how our brains are organized. We can finally start to build a unified map of the brain in action. And this leads to a super interesting question. We know that combining all three senses, video, audio, text, works better overall. But is that true for every single nook and cranny of the brain? Or are there special places that get the biggest boost from this all-at-once approach? And it turns out there are. The biggest performance gains, the places where Tribe really shines, are in the brain's associative cortices. Now, these aren't the basic areas that just process raw sight or sound. No, these are the brain's high-level command centers, the managers, the parts whose entire job is to take all that separate information and integrate it into something that actually makes sense. So for the first time, we can actually see what that integration looks like. The researchers came up with this brilliant idea. They assigned a primary color to each stream of information. So red represents text, green is audio, and blue is video. Now, the real magic happens when you see where those pure colors start to mix, because that's where the brain is actively combining them. And here it is. This map is just stunning. It shows us how our brain organizes reality. You can see the pure colors right where you'd expect them, that deep blue in the visual cortex, way at the back of the brain. The green is lighting up the auditory cortex along the sides. But now, look at the blended colors. See that yellow? That's where the brain is mixing the meaning of words, red, with the sound of those words, green. And check out these cyan areas. That's where it's combining visual motion, blue, with sound, green. This is more than just a model. We are literally looking at a map of how our brain builds our world. So what's next? I mean, winning a global competition and creating a map like this is incredible. But for the researchers behind Tribe, this is just the beginning. One of the most exciting discoveries is that the model follows something called scaling laws. Put simply, that means the more data you feed it, the smarter it gets. And the crazy thing is, its performance hasn't even begun to level off. We are just scratching the surface here. With bigger datasets, we're going to get even more powerful and precise models. The paper wraps up with this really powerful idea. It says, this research is forging a path to in silico experimentation. Okay, but what in the world does in silico actually mean? It means we can start using these amazingly accurate AI models as virtual labs for the brain. Think about that. Scientists can test out wild new ideas and hypotheses inside a computer first. They can see what works and what doesn't, guiding their research before ever needing to run a single, complex, and expensive experiment on a real person. It's a safer, faster, and frankly, a revolutionary new way to do neuroscience. So the big thought I want to leave you with is this. Tribe isn't just a better mousetrap for predicting brain signals, it's a stepping stone. It's cracking open the door to a future where we might be able to explore the deepest mysteries of our own minds. Consciousness, perception, memory, not just in the lab, but right inside a machine. What might we discover then?